So today we're going to talk about the unit circle, which is a great way of learning how to read cosine and sine values of different common angles we use in calculus. So today we're just going to focus on what type of numbers are on the unit circle and how they pair up together, and we're only going to focus on the first quadrant of the unit circle. So first we're going to talk about something that's very familiar to most people, the Pythagorean theorem, which is a squared plus b squared equals c squared, and it's a way to relate the three sides of a right triangle to each other. Now the unit circle is called the unit circle because it has a radius of 1. In math, the word unit just means 1. So actually, wherever we see this c, we can cross that out and put a 1. So we actually get that in our case, the Pythagorean theorem is going to be a squared plus b squared is equal to 1, because 1 squared is just 1. So now you see over here on the right side of your screen these 5 different numbers: 0, 1/2, the square root of 2 over 2, square root of 3 over 2, and 1. These are the only 5 numbers that appear around the outside of the unit circle, and they all have a buddy, a partner. They all have one other number that they go with, so that whenever you see one half of the pair, the other half of the pair has to show up in the same coordinate on the circle. We're going to use the Pythagorean theorem to figure out how they pair up together. So first let's start with 0. If we plug 0 in for a, we get 0 squared plus b squared is equal to 1. Now 0 squared is just 0, so we get b squared is equal to 1, which if we take the square root of both sides, we get that b is equal to 1. So we know that wherever we see a 0, its partner in crime is going to be a 1. So there's always going to be a 1 where there's a 0. Okay, so the next number in the list is 1/2. So if we plug 1/2 in for a, we get 1/2 squared plus b squared is equal to 1. Now 1/2 squared is just 1/4, because you just square the top and bottom of the fraction, plus b squared is equal to 1. Subtract 1/4 from both sides, we get that b squared is equal to 3/4. Again, we're going to take the square root of both sides to figure out what just 1b is equal to. So we get that b. Now when you take the square root of a fraction, remember that it's just the square root of the top, so the square root of 3, over the square root of the bottom, which is the square root of 4, or 2. So everywhere we see a 1/2, it's going to pair up with a root 3 over 2. So again, we're going to draw another little arch connecting those two. So we only have one more number left in our chart. So hopefully it pairs up with itself, and we can see if it does or not by plugging into the Pythagorean theorem again. So we're going to plug in root 2 over 2 squared plus b squared is equal to 1. Now the root 2 over 2 squared just gives us 2 over 4 plus b squared is equal to 1. I'm going to go up here. If we subtract from both sides, we'll get b squared is equal to 2/4. Take the square root again. We get that just 1b is equal to the square root of 2 over 2. So root 2 over 2 does in fact pair up with itself. It's kind of like an identical twin. There's just 2 copies of the same number. So now that we know how all 5 numbers pair up in the circle, we can actually go and start putting them on in the appropriate places. So on your screen now is a copy of the first quadrant of the unit circle. And one thing that we should probably talk about is the angles that you see on your screen. So the first angle down here is a 0. So that's because we haven't moved anywhere from the x-axis, which is where we start measuring. The next one up is pi over 6, and we're going to measure in radians today. So then we have pi over 4, pi over 3, and pi over 2. So in the first quadrant today, we're just going to talk about 5 different angles. So the first one we're going to talk about is down at 0. Now, remember that the unit circle is just centered on the x and y axes at 0, 0. So this red point down here is just the point 0, 0. If I draw a line from the center over to where the angle 0 hits the edge of the circle, I just have to draw a horizontal line. So I don't have to go up or down at all to get to the angle 0 point. So I know that my y coordinate is going to be a 0. And down here, we see our pairings again from the previous page, and we know that whenever we see a 0, by using Pythagorean theorem, the other value has to be a 1. So the coordinate point at the angle 0 is 1, 0. So now we're going to go up to pi over 6. What we're going to do is we're going to drop a vertical line down from the point where pi over 6 hits the circle, which if you want a fancy math word for that, it's called an altitude. We're going to draw this nice blue right triangle. Now if you're looking at this triangle on your screen, you can see that the horizontal leg is much longer than the vertical leg. And the horizontal leg goes along with your x-coordinate, and the vertical leg goes along with your y. So we know that the x-coordinate has to be bigger than the y-coordinate. And because we definitely have an x-coordinate and a y-coordinate, we can't be in that 0, 1 pairing. And because they're definitely different lengths, we can't be in the root 2 over 2 pairing. So that means we have to be using this 1/2 and root 3 over 2. Now, which number goes where? Well, root 3 over 2 is a bigger number than 1/2, so it must be with the x-coordinate. So at pi over 6, we get that root 3 over 2, comma 1/2. Okay, we have 2 angles down, 3 more to go. So we're going to go up here to pi over 4 now and do the same thing. We're going to drop an altitude down, put in our right angle, draw across the horizontal leg. Now, for those of you who know how to convert degrees into radians and radians into degrees, might know that pi over 4 is the same thing as 45 degrees. So I actually have a 45-degree angle down here, which if I have a 90-degree angle over here, that means I also have a 45-degree angle over here. And if you know anything about right triangles, you know that a 45, 45, 90 triangle has to be isosceles. So these two green lines have to be the same length. And if they're the same length, it means the x and the y coordinates are the same number, which means we have to be in that root 2 over 2 pairing. So here we get the coordinate point root 2 over 2, comma root 2 over 2. Okay, so again, at pi over 3, we're going to do the same thing. I'm going to draw a red right triangle this time, drop our altitude down. Okay, so now we're in a situation again where we don't have an isosceles triangle. And the vertical leg here is much longer than the horizontal leg. So we're again going to be back in that 1/2 and root 3 over 2 pairing. And this time, the root 3 over 2, since the vertical leg of the triangle is longer, is going to go in the y-coordinate, which means that the 1/2 must go in the x-coordinate. Okay, we only have one more angle to go in the first quadrant. And just like when we did 0, we're going to start at the center, and we're going to draw a line up to pi over 2. Now notice I only have to draw a vertical line up. I don't have to move left or right to get to this point, which means that my x-coordinate has to be a 0 because I didn't move anywhere on the x-axis. So if I have a 0, according to our Pythagorean pairs that we did previously, there must be a 1 here. So now we've filled out the entire first quadrant of the unit circle, and because you know the first quadrant, you can actually use the patterns of how the signs change in each quadrant on the xy plane to figure out what values go around the rest of the circle. So you can either figure that on your own using the coordinate plane, or you can watch part 2 of this video, which is coming soon, and we'll go over the whole unit circle together. Now you might be thinking, how does this help me? How can I read a trig value off of a circle? Well, on the unit circle, instead of reading coordinate points as x, comma, y, we let the x value stand for the cosine of some angle theta, and the y-coordinate lines up with the sine of theta. So for example, I could say that my pi over 6, cosine of pi over 6 is going to be root 3 over 2, and the sine of pi over 6 is 1/2. And whenever you're measuring angles, they always label them over here in the circle, but the angles are actually over here. So let's draw a big theta down there. Okay, thank you for watching. Stay tuned for part 2 of this video, and have a great day.